Hello and welcome to the EPROM 9. God, it's been a bloody long time since I've uploaded anything. And well, putting this together is all his job. I let him do the editing now because I'm too fucking lazy. But this is the final part to the Skutter build, which all these recordings are a minimum of about a year old because procrastination, ADHD and autism for the win, and procrastination is something I am an expert on, always have been.
Yeah, it's currently April 2025, and most of this footage is from April 2024 or before, apart from a few clips at the end.
Yeah.
Anyway, to the video.
Yes.
Right, so Ephraim, you care to explain to your viewers what you're doing here then?
Upgrading to the I2C control system, and we've run into a problem where we've already killed 2 nanos in this project, have 2 die on us, which are in a dead pot. And we are currently trying to debug why this one's decided it wants to be short and then it doesn't want to be short. Because it should light up when we turn the power on. But it's not. I'm going to grab a power bank and plug the USB into it and see what it does. Excellent. Because otherwise I'd have to spend like 5 years hunting around for one in this shithole. Power bank. Have we killed that? Oh no, Arduino's not dead. It's doing... Oh, something's smoking. Something just went smokes as I turned it on. Want to see a smoke again? I think the regulator just burnt out. Yeah, there's something shorted in that and I don't know what it is. Cool! That's number 3 Arduino we've murdered somehow. Grr.
I think it might be worth socketing that Arduino at this point.
Yes, I'm going to sit and think on that for a bit.
Right, I'm here. I've had a quick look at it. Somebody over there made a mistake, and where he put the screw in, the screw is connected to the ground plane. The screw is also touching that positive wire there, which is creating a dead short between V in and the ground. which would explain the magic smoke. So Sam, what do you think about the fact you popped it?
Fuck's sake, that's number 3 Arduino Nano that's been killed in this thing. Probably what's been killing them all along is fucking shorts like that. And it's just, But we have at least found out exactly why, because where I expanded the size of the hole, so the screws I have would fit in there, but the ones I did have are too big, because all my screws are salvaged, is turns out that increasing the hole also exposed the negative ground plane and well pop. You screw it down and suddenly the screw becomes a negative and you don't even realise until, well, you've killed yet another Arduino. Hopefully this is the last Arduino this project claims. On the upside, it shouldn't have taken any of the other things with it. And also, Nano creators, make your fucking screw holes bigger.
I think they're standard size screw holes on them.
Yeah, for itty bitty tiny screws that you don't find in much shit. There it goes. Came off easier that time. Alright, got to desolder this. I'm going to try and fix this Nano rather than replace it. That's fine. There we go, and then... And then, when we grab our USB-C cable that has gone hiding, here it is, it should light up and do the flashing script. Boom! It lights up and does the flashy script. Yay! We revived it rather than being we've arrived it. How many Arduinos have we popped already? 2, so this is the 3rd. So yeah, we don't have to move to Arduino. That can go on the floor to be mopped up by Hetty later. Yeah, fixed! And go over to the workbench and remount that back in there and make sure I don't put a screw in there. Yeah! It's not visible on the camera, it's visible to the eye. There's some copper that has exposed itself there. There's really not a lot of good places to put a screw through other than there and there. That one doesn't seem to have any internal. Yeah, be careful where you put your things because you pop your bloody chips and yeah. I think the power supply down here for the 5 volt was just dumping it in regardless. That's the point. I should test if I've killed it actually. I know. They can see the multimeter output.
I'll get a better angle if you want.
Yeah, that's fine. Right, negative and positive are there. So if we go done. Oh, I could just do it here. That's 6 volts. Oh yeah, I need to measure it up here, won't I? So we should, if we haven't popped for the regulator as well. We're getting 531, which is close enough. It was 5.2, but temperature tolerances are a thing. Cool. Back over to the computer desk, and I can put this back in the head and hopefully not have any shorts this time. I'm going to double check that. We have screwed up another nano. Don't burn myself. Yay, I didn't burn myself. There's a blob flying down there though. Right, this is going to be the nasty one to desolder. I used that horrible flux on it last night, so it'll probably try and gas me to death. There we go, and that is the nano freed from its torment. So let's actually do a bit of... Where's the mold? I'm going to do it at the other desk, the debugging on this. Right, I got my little USB here. That's already at full brightness.
Okay.
Cool, I can also desolder those if I get this working. So there's two things that's gone melty, either the diode, which is a common failure mode on these, or the transistor. If it's the diode, I'm just going to short it. So I don't think this one has a... Is that a diode or a capacitor? That's a diode. Cool. Right. Right, let's see what is... let's see what's gone pop. Let's check the diode because they're quite a common suspect for failing. I saw. Yeah, that's fine. Stay that way round. Diode's fine. That means probably going to be the voltage regulator that went smoky smokes. Cool. Heat gun time. That is on, what's its temperature is it set to? I don't know. Where's my tweezers?
They're here.
Cool. You bring them over, please.
Watch yourself, don't make yourself.
Random screw there, that can go with that.
Right. And keep yourself in the middle of the mat.
Take the cable off because it keeps flipping it round. Realise I'm holding the... there we go. We are at... Oh, we're never going to melt anything at 196. That needs to be up at least 450.
400? 450 you'll melt the PCB.
Oh, I've melted... haven't managed to melt a PCB at 450 yet. I love the whistling noise it makes. I tend to burn myself with the heat gun because, well, it says it's a 400. There we go. There's the little suspect of thing. Now we go in the dead Arduino pot. Pull out the previous nano, which I... Dead micros, dead ESPs, we've got loads of dead. Here's the previous one. There's actually a hole in the chip, which is probably not visible on camera because it's an itty bitty hole that I was able to stick a knife end into. But it does light up when you plug it in, which tells you the regulator's still alive. I wonder how many problems this little shorting thing, of course, has. I need to plan. See, it still lights up. He's not dead. Well, he is dead, but he's not dead. He's not dead, Dave. Right, make sure the dead one's over there somewhere so I don't mix them up. Because that's the stupid thing I do. None of these Arduinos you get off AliExpress are the same as each other. I have to see if these ones light off on the C to C, because these ones don't. Some of them do, some of them don't. There he goes. That did not take long. Yeet him back in the dead component box. shame that ESP cam module was dead. Oh, we lost a button. Oh, the button came off of it as well. I didn't intend for that. We got a spare button. That can go in there. Those are quite useful, those little buttons. Right, that's the dead one. Hopefully this works. If it doesn't, well, I can always just grab another nano. And just live with the fact I've murdered yet another nano on this project. Oh, you put that thing back in, didn't you? No, you didn't. Good boy. Right, where's the solder reel? There it is. Beep. That's up to temperature. Yeah, this is the reality of projects. It's like you blow up loads of stuff. Always have spares. This is one of the things I like about the fact I actually have money to be able to buy bits, because, yeah, it turns out DIY is not as cheap as people claim it is. I know that hasn't soldered properly, but... Alright, so, take number 2000,026,000,026. We've got a few things to solder back on, but first, let's not mount it with the offending screw at that corner, which causes all the problems. I notice there's a slight problem there, because it's the same problem there, but it hasn't caused issue. In fact, it's the same problem all around. That's got some exposed copper. I think I see what's killing my fucking nanos. It's these bloody screws. How the hell am I supposed to mount this thing?
Hot glue.
It's supposed to be repairable, but the ironic thing is making it repairable has made it need to be repaired multiple times.
Custom 3D printed bracket.
Yeah, that wouldn't be a bad one. Let's get this soldered up anyway, all up to the electronic keys and all that jazz, and try again. Where did the power wires go? There they are. And remember, kids, screw-ups are just part of the game of doing this sort of stuff. You will make mistakes, you will fail, and you'll pick yourself up and try again. Until you do get it right. Good, that's up to temperature. That's got mangled in with that. Make sure we've got some nice solder blobs to work with. Find the wires that have gone hiding again. Let's not catch the pigeon, it's find the wires. Find the wires. The amount of effort they put into trying to catch that pigeon, it's a shame they never did. Same with Coyote. I always used to vouch for Coyote catching the Roadrunner. He put in so much effort and work, he deserved it in the end. He deserved that dinner. There was actually an episode of Tom and Jerry where Tom actually successfully catched Jerry in the dark. That was at the very end. So Tom got his reward in the end. Why can't Roadrunner and Dick Dastardly? Dick Dastardly got cheated out the first place on the Wacky Races several times. When another character do essentially the same trick he did, and they'd be like, yeah, that's good. That's allowed. But when Dick Dastardly did it, double standards. Right, we are on the wrong tab because we need the I2Cs to know what colours go where. So A5 is green. I haven't programmed this, by the way. It's still got the default blink sketch on it. Right, this is the real fun one. Soldering the negative to that. So I'm going to put a nice big healthy blob of solder on the soldering iron. Kind of handy having a pine sill on the desk and then the Heiko on the workbench, so I can do soldering on both. Oh, it's melting. Stay on there. Haha, success. Success, my children, success.
Who's Cess?
Don't know. Plug in that. Grab the I2C. No, the USB-C. Too many things have C in the name. And boop. Cool. That's connecting. The blink sketch is running. Actually, having a blink sketch running on it is actually quite a useful thing because at least you can see if you popped your nano. Then negative connects to there. And positive connects to there. And that should make it so these two boards power. I don't know if this one has an LED on it. Nice. One of the servos powered up as well, which was good. So we got the I2C multiplexer board doesn't have it, a power LED on it, but the servo motor driver does, and of course the Nano does with its blink sketch happily blinking away. So now I just need to mount this down without shorting it out anymore. I'm going to have a little gander around and see if I've got plastic screws or anything I can use. I don't think I do, but I'm going to have a little gander and see what I got in my various screw pots that I have. I found a box of these. Is that recording? I can't tell.
It's recording.
Cool. I found a box of these, which I've got for building quadcopters years ago. And these are plastic, so they shouldn't melt the thing. Where's my iFixit kit? There it is. I don't care if I cross-thread these. They look about the right size. You know, about is good enough. Dun 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 dun. Which ones do they fit in? They are 4mm. Cool. I should get another box of these. Annoyingly, I think they're M2 or something. I don't remember. Years ago I brought them. Probably decided to snap. It is going in slowly. But yeah, there's always a solution to problems, even if it is just something you brought like probably like 10 years ago now. That's scary to think about. Is it actually going in? Yeah, they're going in, they're just slow. I don't think they're the right thread pitch, so I'm just kind of like forcing them in basically. This one's definitely being a little more stubborn. This will at least stop them nano shorting out all the time and will hopefully lead to the constant and actual not death of nanos, because, well, as much as they're cheap and I quite often order them in bulk from AliExpress, I don't have an unlimited number of them and they're not exactly free. Although the ones off AliExpress are a lot cheaper than the official ones, which are about 20 quid. I have an official one. It is... here it is. It's attached to a little, got it matte lens, like 2011 or something. It's got copyright on it. It says like 2011 or something. My Uno. Use that for a lot of prototyping stuff. Little too... oh, that's annoying with that negative. I've got an idea. I'm not risking deep. Bye-bye, screw. You want to retrieve that screw for me, Ash?
Where is it?
Gravity took it down there somewhere. Thank you. Stay. Because just because those screws aren't useful for this project doesn't mean they're not useful for others. My partner thinks I'm a hoarder. I disagree. I don't solder to those pins, so I shouldn't melt these. Proceed to need to use D13. Are they screwing in? Yeah, it is. No, it's not. Now it is. Cool. We now need a much longer bit of negative wire, but now when we power up our Nano, it powers up and doesn't go pop. I'm lucky I didn't pop the other regulator, probably because it was higher current and could take it. But yeah, be careful if you extend these sides of these holes on the corners. There's a lot of ground planes that go right up to them, and you think your screws are isolated, and it turns out they're not as isolated as you think. They're quite the opposite, and 3 Arduinos later, you're already repairing your third one after just installing it. And now it's time to put it back together, because it hasn't, because we've fixed the popping, fixed the issue of it popping. Almost took down a Dwarf Skutter. I don't want to do that. I don't have to rebuild it from scratch. Because this thing is months. I don't know how far off a year it is of work, but it's definitely months of work. It's definitely the most complicated project I've ever done. Yeah, we will grab that. Yeah, definitely found probably the cause of all the issues I was having. Get that in there, get over that side so it's not fouling with the that mechanism. Pop the USB in there so I can charge it remotely. Well, program it remotely. Pop in the back connector. Boom. Then it's just pop in the screws and pop on the top half. And he'll be good to go for programming. Fish and chips earlier was nice. I managed not to spill it on myself for once. Only because I used the curry sauce thing as a bib. So I spilled it on that instead. I reckon we can get this working by the end of the month. Might not have all the functionality and bugs figured out, but
Try and get it ready for ScottyCon.
yeah. See if you got to take it to the conventions. Got to take it to the conventions and.
Want to get it ready for ScottyCon 2024?
Yeah, why not? Right. That goes there. This spring goes on here to give some ballast. I'll put it the other way around just in case. That does give it some ballast. Now, let's just do a basic power on test.
Or stick your head in the way.
But yeah, as you can see, the Arduino's not popped yet. It's still doing the blink sketch. Turn it off. Let's put the top half on. Retrieve the servo thing from there. Yeah, I can't help it if I put the head in the way occasionally. It is a bit of an awkward faff. Getting bits in. Make sure I get the negative and positive the right way around. I don't want to have to rebuild this circuit. Although at least I could just pop 555 and 4017 off. Come on, there we go. Then the magnets will hold it in place, get the eye up so you can see the flashing pattern. Whee, sinky sinks. Boom. Fixed, working, upgraded to I²C. Next bit is actually the hard part, coding it. Oh, that's going to take some hours. Good job we got like over 2 weeks.
Just.
I reckon we can get something going by then. But yeah, success. I'm happy. Oh, that was lucky. The screw attempted to make an escape. That screw isn't 100% necessary, but it just helps stop the head flinging itself apart. The magnets do hold it, and that'll go up over there, but I kind of want to make sure we're finished with all the bugs with the head before I have another need to take it off because another servo burns out or something. Don't like the fact they do that on boot. But yeah, if I look in there, I can see the blink sketch running. I'll point up so you can see inside through the hole. I still need to sort out the actual gloves that go over these fingers. I'm still debating whether I'm going to use 3D printable filament, that TPU filament, or if I'm going to just use standard PLA, make a mould of it essentially, and then just pour silicone in. I'm not sure which would be the best method, but all methods require 3D printers. Need to sort that out again. Right, I think we're done here. Boop.
What are we doing now then, Simon?
We are building an adapter so we can basically parallel up the power supplies in the motor driver modules for the linear actuators. But first I need to sort out this. Actually, I'm going to grab a fresh one because that one's all warped and nasty and minging and being a pain. So here's one I did cut up earlier. And he goes in there like that. I struggle with soldering. The software for this has been an absolute nightmare, but I think we're getting there. but it's basically we're in the process of finding where all the bugs and mistakes are and having to try and fix those. So that's data. The other two are power. So on the power and parallel. Stay like that. Use that thing and make it a bit easier. Half the solder fumes. I don't vape, I'll smoke, I just huff solder fumes. Cool, that means the data are different. That means I can grab this one. We keep having power issues where things keep power surging and basically buggering it up. Negative, positive data. So we'll solve on negative first. Fight with the little wire brush thing. Try not to burn ourselves. That's him in. Also, it's on this prototyping breadboard stuff that has a tendency of forming shorts where you don't want them. Shorts that are usually very difficult to remove without dismantling your entire circuit. That means I wanted it on that one, not that one. Because that data already gets ported through nicely. How? Melted plastic. Smells delicious. Smells just like my teenage years. Back when I was a proper pyromaniac.
You mean to say you're not anymore?
I mean, I don't burn as much stuff as I used to when I was in my teenage years. And
Tell that to the batteries in the microwave.
I mean, that was just hilarious. It went proper bang. After like half an hour of faffing around with nothing interesting happening.
That one's on a previous video.
Mistakes, doesn't matter how much experience you'll get, you'll still make them. Alright, cool. And then huff some more fumes. Best fumes are half of petrol fumes because they smell so delicious.
Even better, leaded.
Yeah, that actually smells better. Not going to deny that. Right, so this is negative, positive thingy, hot glue stick.
So Simon, what are we working on here then?
More power, because power is an absolute nightmare on this thing. Whoops. There's no such thing as too much power, so yes. It goes in there like that. I need to go 2 into there, and then on another 3 core, which I need to find one in existence somewhere. I'm pretty much working this out as I go along, so. Negative, positive thingy. So that will go in there, plug will go in there, wires will go out and plug into there. So I need to find the rest of this cable that I trimmed and did something with somewhere if I haven't used it elsewhere. good bit did I say there then? This is the bit where everything goes wrong and explodes in fire and brimstone. Cool. Let's see if it crashes or smokes. What was it? Contact. That's a good sign. Where's the controller?
Do that again.
Do you really want to play with fire here? Is the controller on? Yes, it is. I need to fix the top claw because the link bridge snapped. Not going up and down, which probably means the thing's fallen out again. That's exactly what happened. It was grinding gears, but I've done some tuning to the code. I'm going to do some more tuning to it. That button doesn't do anything currently. They're working as they should. Definitely a bit of a... And it just crashed. Let's measure the voltage. This is the problem we've been running into. This is a massive problem we've been running into. 4.49. This was something we were having on the first version of the head circuit, was it just crashing? Now it'll be an absolute arse to start up. We haven't figured out why it keeps doing this. Now it's fine. However, it is starting up. It is a bit easier to start up more reliably. Interesting. No, still crashing. I think it's the controller that's crashing, actually. No, it's still moving without... Oh, because power to the controller's done through the other bit, isn't it? Controller's crashing. Power to the controller is fed via... It might actually be... What's this reading? Come on, get in there. Yes, it's the power regulators that are powering this that are shitting the bed. We've got power to the Arduino, so the ESP isn't crashing so much, but we're still running into problems with those little mini voltage regulators, which makes me think, how can we get 6 volts at high power? I might need to specifically order a special power supply for RC stuff. You have to leave it a while, which I think is for those caps to discharge. Now if we measure, just out of curiosity, because it surges the rest of the circuit, because everything's drawn off of this. Now it's gone down to 4 volts. is going on here? Why does that keep crashing? I think it's those power supplies that are causing us issues, which is not good because I don't have an immediate fix for those. But I wasn't even able to measure the fucking ESP. Why are you doing this? Why are you... Think I found a problem. Batteries. This one's done me dirty before. 6.73 on the 12 volt rail. I bet you, if I put this one to one side, I'm going to have to do that on a bit of a fancy charge now to rejuvenate that battery, because otherwise it will, the BMS charging thing will complain. It will just work. Oh no, it decides to have a seizure. So much for it just working. Ow!
So, turns out that it's all of our problems are being caused by this one wire. This one wire is the wire for the servo in the neck. If I plug it back in, usually it causes a problem. If I can do this one-handed. Come on, get in the hole. It goes all the way up, and if I start groaning, if I reboot it, it'll start to freak out. But the second I unplug that, it all starts working just fine. As you can see. I feel like that was not in shot, but oh well. So what have we learnt, Simon? What have we learnt?
That servos are bastards. So before I go to bed, we have done this. So this spins round, all the electrical contacts in, but what I've done is I've actually hooked up the 12 volt spinny bit with the little copper contacts up to the head, and now we can spin it around happily. And the servos don't freak out, and the LED eyes continue their flashy pattern, and all is happy and dandy with the Skutter. So yeah, that's actually working out as a good solution. How high current it is yet to be seen, but, well, smoke and fire will prove that one to the brimstone. Yes, all good, and huge amount of help from that one.
Take number 2225.
I'll take that as a yes. Let's watch it fail. Well, it went down fine. But can it go up? This is the real big test. Hey, 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 hey! Might want to play a bit more with the tensioning, but it's doing it. The little linear actuator wasn't powerful enough, but this one is. I just need to mess with the tensioning a bit more to get it so it's a bit further up rather than a bit anemically low. But yeah, shall we show you what happened to the little one that was inside the boom? So you're going with a bicycle cable, a load of 3D printed parts which will hopefully hold up and not end up like this. If they do, at least I can replicate them to infinite amounts. And then a much basically this linear actuator here has the same torque as the one in here, which is 100 kilos worth of force, because it's 1,000 newtons, which translates to roughly 100 kilos. So, woohoo! Success! We might actually be having some success, which will be good, because, oh, this bit has been problematic. This has been the hardest bit to figure out. Here we are doing the Skutter. So we've had issues for a while where the head just randomly crashes. But I've been on the right tracks actually on debugging this, because now we've made it not crash by putting ferrite beads right on the I2C lines coming in, the long ones that go all the way through the neck down to the base. So I got some of these off an IV stand thingy controller, which is down by the computer at the moment, because I pulled them off like a day or two ago. Wired them up with some copper from a motor, because that's an ammo wire, so it's all insulative. And then just stuck them in series on the I2C lines. The other thing I want to add is TVS diodes that clamp it to 5 volts, because I did some scoping, and when Ash is editing this, I'll get him to throw on the images that I took with the phone of the scope screen, that we're getting peak voltages in that particular example when it crashed of 7 volts, because I put it on single shot mode because I wanted to see the spikes. So yeah, we're getting a little noise spike. So did some research on how to reduce the suppression, and there were 2 ways on the I2C, which was TVS diodes, which I haven't installed yet because I don't have any, or if I do, I don't know where they are, and little ferrite beads. So I did some searching in my parts box, dug them out, and now this thing is actually really reliable. You know, it's not crashing, it's being quite reliable. You know, I'm doing the sort of stuff that would crash it normally instantly, and it's still holding on. It does still sometimes crash, but here's the other thing. When I press the little button that triggers the relay that switches the 12-volt circuit off, you watch it, and boom, it resets perfectly every time. I literally just plug this in, and usually there's a whole rigmarole process I have to do to start this up. And it's just working. Just first time straight away, and then, it can be really rough. The Skutter can be really rough with its head. Not crashing, not crashing. You know, really bouncing around. Boom. Still not crashed. I've only got it to crash once of these so far. So I think throwing a TVS diode on the I2C, and I'm also going to throw in some small ceramic capacitors I pull off of SMT ones I pull off of boards, and just stick them down some of the other power rails just as a precaution, just to kill some more of that high frequency finding its way around other places. But this should be the end to this thing killing Arduino Nanos, which is brilliant, because that has been a massive problem. It's killed 3. 1 it completely killed, the other 2 it damaged. The I2C doesn't work on them anymore. But yeah, he's coming along nicely. All moving and all that. I'm not going to move him while he's down here, but yeah, these bits work. But yeah, we are very close. This is a major step in the project, making the head reliable. But I'm going to stop rambling and get back to working on this and doing other stuff.
So, hello and welcome to the end of the video. I don't have a clue how it's put together yet, because I still need to do the voice recordings in the middle and whatnot. But basically that's the state of what the Skutter was a year ago before it went to convention, and then there's going to be a whole load of little clips and pictures that go up and have it all. And also got to have the mandatory little 3D printed ones that one day I will make, the little mini ones that can follow it around. But
yeah, there's many clips of it up on Twitter and other platforms
that I don't have access to, but it's fun seeing them when they do pop up.
It's fine, I got it.
Yeah.